Hello, my name is Rakesh Gujjula. I lead the engineering teams for Azure Database for PostgreSQL services at Microsoft. I have had the good fortune of being in the relational database industry at Microsoft and in the relational database teams at Microsoft for the past 20 plus years. My journey started with SQL Server and on the relational engine aspects of SQL Server. I then went on to work on distributed query processing, quite a bit of query execution on the security side of things, and application model aspects as well. And I spent a couple of years in improving our engineering productivity and our build and test systems as well. My journey with distributed systems had very humble beginnings with the distributed query processing area of SQL and specifically the link server feature and the remote query processing aspect of it. I then spent a few years building the distributed database for SQL Server at Microsoft. And then for the last few years, I've been working on the cloud services aspect, starting with cloud services on Azure SQL DB, and the more recently on hosting open source SQL, also open source relational databases on Azure. In today's talk, I'll go through the journey that we went through for hosting OSS databases on Azure, the challenges that we faced, the corrections that we had to make through during this journey, the lessons learned, and share some of our learnings around hosting persistent systems at scale that potentially can be helpful for everybody listening. A small personal note, I tend to speak a little bit faster and my accent doesn't help matters. So I sincerely hope that this goes without a hitch. All right, let's get started. The beginnings of our Azure OSS databases, the goal for us was to host at least the three major database engines, which is the PostgreSQL, MariaDB, and MySQL on Azure, and at the same time provide the customers with a lowered total cost of ownership, provide enterprise grade features like security, compliance, and also the availability and reliability guarantees that mission critical workloads require, along with built-in intelligence that will help the customers run the databases at a much lower TCO, and also the database administration costs reduced, right? And more importantly, have these services integrate into all the Azure offerings so that the customers can extract maximum value out of these offerings. So that's kind of the starting point of requirements, if you will, for our services, right? And in this journey, when we got started, at that point of time around 2017, we had a very successful offering for relational hosted databases in our Microsoft SQL Server offering on Azure. And this service was built on infrastructure that has been battle tested, that runs across geographies, across practically all regions of Azure, that is secure, provides a good set of supporting services around monitoring, telemetry, and observability. And in net, it was a fantastic infrastructure that powered like literally millions of databases of SQL Azure DB. So this was our starting point. And given the familiarity, given the infrastructure robustness and the familiarity that the team had with the code bases, we used this as a starting point to start our journey for OSS databases as well. So in that journey, we were able to host our services, get them up and running in a fairly quick order, primarily given the advantages that infrastructure provided and also our familiarity with hosting environment as well. We were able to launch the services and get them into our customers' hands at a pretty fairly quickly rapid pace. So once these services were launched, as I mentioned, we had three services. In the first few years, we had 50,000 plus customers. We were regionally present in 50 plus regions, and we had presence in 100 plus countries. The service was one of the fastest growing Azure services in Azure, and definitely was the fastest growing in Azure Data itself for a couple of years. The adoption was significant. The workloads that we got on were ranged from basic uses for test, dev, environments, all the way to mission critical applications for enterprise class customers, which ran into multi-thousand instances in certain cases for our customers. So the database itself, the database services itself were very successful, and like our initial launches were extremely, but adopted very fast. Now, that was from the customer perspective and the business perspective. Jumping into the implementation aspects of it, like how did we go about using the SQL DB infrastructure to host OSS databases, I'll walk through a few sets of things that we did and that helped us in this process and also set us up for the next set of enhancements and improvements that went on. So the first thing that comes to mind when I look at the design of our initial offerings for single server is layers. So we had a set of layers that we had to put in place because of how the infrastructure was built for SQL. So OSS databases are built on open source software, and open source software, by definition, we have to treat it as a hostile software which hasn't been vetted for security to the level that we want it to be. Essentially, especially when you're hosting this in a multi-tenant hostile environment, you need to treat this as unsecure code. And what that translates into is when we are hosting this in our infrastructure, we had to put the engines behind secure container, or rather within a secure container. And this is what we refer to as a compute abstraction, which provides us the security guarantees that we need for running hostile code in a multi-tenant environment within our infrastructure. So that was the first layer. The second layer is, since we are in a multi-tenant environment and given the architectural dependencies that we had on SQL DB, we had to have a network proxy. Right? Essentially, so all your customer application connections would terminate on this network proxy and then get routed back into the backend. Now, this network proxy also provided us the ability to the addressability aspects of it, where you had multiple instances of these hosted on essentially in a multi-tenant environment, and the customer was able to refer to their databases with the connection string itself. Now, this connection string had to be changed, is a non-standard connection string because of the addressability aspect. So it had like username at server name instead of your typical username with your database connection string. So that's the second abstraction layer in terms of our networking side of things. And from a storage perspective, in order for us to have a common layer of storage for all the OSS databases, we kind of ingeniously and very innovatively used an abstraction layer that was common across all the board and we were able to host our OSS database engines on this without making any changes to the DB engines themselves. And so this is the third aspect of the abstraction layer. And one note, while it's not a true abstraction, we also, from an operating system perspective, we used Windows. And essentially what it meant is we took the Windows versions of the database engines and used them to host on these things. So just to give you a picture, imagine the database engine being hosted along with these layers, one for the compute side of things, the networking aspects of it, and the storage side of things. And this setup has helped us get us into the market much faster and much quicker than with the capabilities that we wanted, that we spoke about earlier, in a very quick fashion, right? And so that was fantastic. And the adoption actually proved that the usefulness and the applicability of the solutions that we were providing to the customers as well. However, there's always a however. It came with its own set of challenges, right? Now, these challenges ranged across different aspects. I'm going to go through a few of them and to set the stage to how we solve these as we progress along with our journey in the next set of offerings, or the evolution of these offerings. So as you can imagine, the layers of abstraction, there's complexity that's built into the system, and complexity translated into multiple side effects of impacting scale, impacting productivity, impacting debuggability, or impacting our operability of the services as well. So I'll go through a few of these aspects and then transition into the solutions for these in our next set of things. From a networking perspective, the proxy itself added significant amount of latency to connection, both the connection establishment aspect of it and the workload itself in the cases where the client drivers did not support redirection. So in the case of redirection, what the proxy does is you establish the connection, and the connection establishment does go through the proxy with authentication. And then it offloads the subsequent connections that come in to the backend directly. Now, in order for this to happen, the client driver has to support this thing, right? And in the open source case, except for a couple of cases, most of the drivers were not supporting redirection. That translated into increased perf latency for your workloads. And especially at scale, you would see connection drops after you reaching about 1,000 plus connections in certain cases. Right? Now, this is one aspect of it, which is the networking, the latency and the perf and the scalability problems introduced by the networking aspect of it. On the storage aspect, the abstraction layer, as you can imagine, is not fine-tuned for each of these database engines. Right? By definition, it's a common thing that hasn't been changed for all the things. Now, that didn't take into the nuances of each of these database engines, storage engine usage patterns, which translated into reduced perf in certain cases for certain workloads, right? So that's another aspect that was a problem. And of course, the compute layer, while it was an extremely efficient, secure container, there were still aspects of it that contributed to the increased resource usage or increased cycles in certain cases for the CPU aspect. So that's from a performance bucket. Now, the multi-tenant environment itself also made implementation of features like managed maintenance windows, or essentially customer managed maintenance windows, where the customer defines their maintenance schedules, extremely challenging to implement. In certain cases, it was like flat out impossible for us to go implement it. And the added complexity in the stack naturally translated into a certain set of challenges with engineering productivity. Our debuggability of the stack and some certain problems were like extremely complex for us to go operate on, right? And that impacted velocity as well. And the fact that we hosted this on Windows also prevented us from adopting the innovations that were happening in the open source, especially in the cases like PostgreSQL extensions, which were primarily targeted for Linux. And it was challenging for us to go onboard those things into our product. So in spite of the success of the services, in spite of the extremely broad adoption and extremely deeper adoption of the services, we still were left with these challenges. And in order for us to grow and grow at the pace that we wanted to grow and accelerate our innovation or accelerate our services growth, we had to go make some changes, right? And this was what prompted us to go look into our next generation or next iteration of our platforms. And that's what I'll spend the rest of the talk on, and how we went about solving those challenges as well. And this set of services, the flexible server, were successfully released as generally available services in December of 2021 and are now being used by customers across the world as well. So let me quickly walk through the architecture, go through the specific scale aspects of each of these things, and then tie all these things together and close out the conversation. So as you can imagine, hosting versus any relational database, or for that matter, most of the services on the cloud side, has three broad components. Right? One is the control plane services. In the Azure case, they host the ARM endpoints. They have a sort of workflows for our provisioning, our upgrades, our rollouts, or server management, including parameter changes or configuration changes and such. So that constitutes the control plane services. Then there is a set of manageability services, which comprise anywhere from backups, auto archival, so storage management, security token management, and so on and so forth. So these are like internal manageability tasks that run against the managed service or the managed instance of the database engine. And of course, the database node itself or the database engine itself on the back end, which hosts the database engine services. Right? And on the database node side, there's a certain sort of accompanying services like our telemetry. There's a configuration manager that manages the database instance itself, and a set of networking constructs and components that are built on the DB node that allow us to do things like VNet injection or provide things like private link and such. Right? So these are the three different components that we have. Now, if you notice in the architecture diagram, we don't have the layers that we spoke about earlier that were impeding or like were causing certain sort of the challenges that we look into. Let's walk through the layers that we had in the past and how we managed to remove them and what the consequences of those were. So on the networking side, we don't have a proxy anymore. So we provide direct connection to the node, to the customer's application. So essentially, there's no need for a custom connection string anymore. And there's the scalability of the component itself is now not gated on a proxy that is now which was multi-tenanted in the past, right? So the scalability is now practically just limited to is governed by the compute resources that you have on the DB node. And we provide customers the flexibility to go scale up, down, and also provide the flexibility to to request any version or any SKU of the compute node as well. So that kind of solved the networking aspects of it. And on the compute and in the networking side, just to add to that, we built upon the native Linux container networking technologies, which the Azure networking team has enhanced offerings of that, which allowed us to provide very secure VNet injected offering to our customers, which is not just performant, but also extremely isolated and provides an isolation from our management traffic and also the client customer application traffic, and meeting the requirements of like some of our highly like secure and our customers who require extremely high security guarantees from the service. Right? So that's from the networking side of things. On the compute side, we host on Azure Linux VMs, right? And Azure Core provides us the services at a compute level to scale, to efficiently provision these resources, and more importantly, provide the flexibility of offering a wide array of SKUs for our customers, anywhere from burstables all the way to the high-end memory optimized or general purpose, or the M series and such machines. On the storage side, because of we were able to take advantage of the innovations that were happening on Azure storage and directly plug into the Azure storage ecosystem without any additional layers in there. So what this translated into was like we could scale the storage independently pretty much with a slight set of changes on our side and have the engines directly talk to that. That's one thing. The second thing is the innovations that were happening on the Azure storage ecosystem itself, whether it's providing ultra disks or providing snapshots, and any of those things were now accruing to our customers through direct like features for them as well, right? So with enhanced backup speeds or enhanced restore guarantees and such. So that was on the storage side. So given the compute, the networking, and the storage, the three-layer removal from this thing, it was much more simpler in its implementation on the database, on the data node side of things, which translated into better performance, better latencies, better throughput in a lot of cases as well, right? And coming to the control plane and the manageability plane side of things, we took the standard industry practices and enhanced them a bit to go much more driven through the microservices architecture, extremely loosely coupled services, which where we were able to scale them, we were able to develop them, deploy them independently, and which not just provided us the agility to go do these faster, but also have the ability to scale these interdependent systems much, much, much faster. And there are many number of these examples, anywhere from our front-end throttling services all the way to our provisioning workflows, to our server management workflows, which are now have the capabilities of auto-scaling. They do like independent deployments across the board, right? So that is essentially the control plane and the management plane scalability aspects of it. So net, if you look at it, we followed if you have to look at the key scale aspects of it, like loosely coupled microservices, as I was mentioning, from the networking side, direct connectivity without any proxies, which with the added benefit of adding connection poolers like PG Bouncer in the PostgreSQL case, or like the MySQL proxy on the MySQL case. And on the storage side, we were able to scale along with on the IOPS side of things and also on the sizes side of things as well, right? With native integration with Azure storage. And one of the important aspects that we were able to scale was our operations without so hosting hundreds of thousands of instances with almost a fairly static cost from a human engineering perspective for operating these things has been a challenging and a very rewarding experience as well. So we have what we call our autonomous operations, which include self-healing, self-detecting components that run at scale on our services that we offer, both on the control plane service side of things and also on the data plane side of things. And of course, the added advantages that we had around like seamless application compatibility and the migration onto Azure was also beneficial from this perspective, right? So from the scale aspects of it, that's how we went about solving those things. Now, coming to the key takeaways and what we learned through this process and how we can apply as we go forward, right? One of the key lessons was just adopting and extending open systems, right? This was very critical for us. Both when I say open systems, it's like open source world or open within the company at Microsoft as well, right? This allowed us not just to move fast, but also have a very mature and stable set of components that we could build upon and contribute to, of course, and to enhance, right? And having a clear service decoupling helped us scale things independently, move things much more agile fashion, and get the solutions out faster. Zero overhead without any layers, as we spoke about, multiple advantages around that as well. Extensibility was one of the key design points as well, to make sure that this is extensible across multiple dimensions, both for our customer needs and also for our internal needs. Portability is an aspect that we typically would have ignored, but designing for portability, where we assume that the system is going to move across hosting environments, whether it's on-prem or some new evolution of things that came along, was critical and has helped us quite significantly in this journey as well. And as I spoke, the operability aspect of it as well at scale. So those were some of the key takeaways of our experiences building these solutions on Azure. And while we made significant progress in these services, we still have a bunch of work to do to enhance our service offerings for our customers, and also on the architectural and the technical side of things, which I personally am excited to. I look at the next set of journeys as, my past couple of decades around distributed systems as the first chapter and the challenges that we have ahead of us, the second chapter. And I'm really excited for this journey. Thank you so much for your time and hope this was very helpful for you.